Okay, so in this video we're going to talk about the quotient rule. I'll start by stating the quotient rule. So if q of x is the quotient of f of x and g of x, then the derivative, which we call q prime of x, is going to be Okay, in this video we're going to discuss the quotient rule. I'll start by stating the quotient rule. So if q of x is the quotient of f of x and g of x, then the derivative of q of x, which we call q prime of x, is g of x times f prime of x minus f of x times g prime of x, all over g of x squared. And one way that I remember the numerator of this, which is sometimes hard to remember, is it's low d high minus high d low. Low is g and high is f, so low derivative of high minus high derivative of low. We can also write this quotient rule in Leibniz notation. So dq dx, which is the derivative of f over g, is equal to g derivative of f, so df dx, minus f derivative of g, dg dx, all over g squared. Okay, so let's do a couple examples involving the quotient rule. Our first example, we're going to look at two functions, and we're going to derive both these functions. So the first function is x squared plus 3 over 2x minus 1, and the second function, which we'll call h of x, is the cubed root of x plus 1 all over x minus 1. So the derivative of q of x is going to be low d high, so low is 2x minus 1, d high, derivative of x squared plus 3. And I like to use Leibniz notation when I'm showing my work. And then we have minus high d low. And then that's all over low squared. Right now, in the next step, I'll compute the derivatives. So the derivative of x squared is 2x, the derivative of 3 is 0, and the derivative of 2x is 2, and the derivative of negative 1 is 0. I'm not going to simplify this. We'll just call that our answer. All right, let's move on to the second one here. The derivative of h of x is going to be low d high. Low is x minus 1. Derivative of the high. I'm going to rewrite the f of x, the numerator, as x to the 1/3 plus 1. Not taking a derivative, just rewriting it. So in the next step, when I take the derivative, I can use the power rule. And then minus high, x to the 1/3 plus 1. d low, derivative of x minus 1. And that's all over x minus 1 squared. All right, now in the next step, I'm going to compute my derivatives. Derivative of x to the 1/3 is 1/3 x to the negative 2/3. And the derivative of x minus 1 is just 1. Again, I'm not going to simplify. That will be my answer. Okay, let's do another example. Call this example 2. So in this example, I'm going to give you a function f of x over g of x, and I'm going to ask you to find q prime of 2. And we don't have the functions as formulas, we have the functions f and g as graphs. So here's the graph of f. And here's the graph of g. This problem we're going to start by writing out the quotient rule. So the quotient rule is low d high minus high d low. To evaluate this function, this derivative function at 2, we're just going to put 2 everywhere there's an x. And then we'll use our graphs to figure out what these values are. So we'll first figure out g of 2 and f of 2. So f of 2 is 2. The output at 2 is 2. And g of 2 is 3. That's just looking at the outputs of these functions at 2. And now we're going to compute the derivative at 2. So the derivative at 2 is the slope here. The slope here is down 2 over 1, so negative 2. And g prime of 2, the derivative of g at 2, is the slope here. And you can see it goes up 1 when you go over 2. So that's going to be 1/2. All right, now we have these values. We just put them in. So we'll have g of 2 is 3, f prime of 2 is negative 2, f of 2 is 2, and g prime of 2 is 1/2. And the denominator is 3 squared. Simplifying this, we get negative 6 minus 1 over 9, which is negative 7/9. All right, I hope you found this video on the quotient rule useful.